Okay, let's get started. It's actually a fairly reasonable turnout for the last session of the day. I was worried this is the death session and I didn't actually think anyone would turn up. So thanks everyone for turning up. My commitment to you is I'm going to get you out of here before the hour is up. And so 20 minutes early or so, without rushing through the content, but then you can get to your buses and get to Movie World and that sort of stuff. So that's my commitment to you. And also it gives us a lot of time at the end if you want to come up and ask questions and discuss some different scenarios. So this is ATC 226, Windows Azure Hybrid Architectures and Patterns. And for those who I haven't met, who came to my session this morning? Cool. Who went to Scott Guthrie's sessions? Okay, cool. There's no overlap, so you'll be happy. This session is a 200 level architecture session. So I'm not going to show you any code. What I'm going to show you is lots and lots and lots of architecture patterns and lots of, and not words, actually pretty pictures essentially about different hybrid architectures and scenarios that I've seen over the last kind of 4 years with working with Azure and what the evolution of that is. And so essentially they're the two things I'm going to go through. One is that, and the second is I'm going to go through a little bit of the technology behind how you make some of these hybrid architectures actually work. Yeah? And so for those who weren't at my session this morning and I've never met before, my name's Graham Elliott. I work for Microsoft. And my job is to basically work with independent software vendors across Asia to help them implement solutions on Azure. Yep. So I have, as Scott Guthrie says, 3 fluff sides. So apologies that they're high level and fluffy, but they're important to set some context because I want to make sure we have a common understanding of what, when I talk about hybrid cloud environments, what I'm actually talking about. And so to start off, we've got this continuum. Everyone's seen this continuum before, of this idea we got infrastructure service, platform as a service, software as a service. A few heads nodding. If you haven't, the idea is an evolution from this idea of virtualized data center is infrastructure as a service. And the main thing about this is you as the consumer or the tenant of that platform are responsible for its maintenance. Yep. So essentially you get a virtual machine, you do whatever the heck you want with it, right? So you have a very high level of control, very low level of abstraction, and you have more complex management in the form of you need to actually patch the server, you need to deploy your own operating system, et cetera, et cetera. Sort of a level of abstraction above that is this idea of platform as a service. And so the idea of that is instead of you operating at an operating system level, you operate at the application level. So you deliver data, you deliver schemas, you deliver your solution, but then the cloud vendor takes care of everything that's under that. Yeah? So you get a higher level of efficiencies from a management point of view, but obviously you get a lot less control. You can't tweak how we actually run that VM for you. And then the level above that, again, is this idea of software as a service. And this is where you're consuming an end solution, right? And there is a little bit of misunderstanding. So a lot of people think software as a service, hey, it needs to be Office 365. But there's actually a lot of software as a service solutions, and a lot of what we'll talk about are actually little pieces of components of a solution. Maybe it's a DRM component, right? Used for adding DRM to media files. Maybe it's a free text indexing service. Maybe it's New Relic if you've seen, if you were in Scott Guthrie's session. That's all software as a service as much as Office 365 is software as a service. You don't build any of that software. You consume it, you use it, you pay by the month, pay by the day, whatever you do. Make sense? Okay. We also have this concept of deployment models. Right? And this is where our hybrid IT or hybrid cloud view of the world comes into it. So we've got private cloud, and we actually differentiate between virtualized data center and private cloud. So the idea with private cloud is you run it in your data centers, you pay the rent, you pay the hosting fees, whatever it is, you own the hardware, but you still have capabilities around what we call cloud tenants, I guess. So it's still self-service, so people don't have to fill out a form to get a VM deployed. They can still, within your organization, go and deploy their own VMs or consume VMs, right? There's still a level of scale. It's not infinite scale, right? But there's still a level of self-controlled scalability There's a level of pay as you go or charge back to the business as you go. So it's got some of these cloud tenets. It's awesome because it gives you infinite control, compliance, blah, 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 over what you do. The obvious disadvantage is it's really expensive, right? Operationally, OPEX, CAPEX is very expensive. So what emerged, I reckon probably the first one I saw in government was 15 years ago, this idea of community cloud, right? The idea is you get a bunch of like-minded individual companies, and you saw this a lot in government, but I also saw it a lot in the EDI space around transport. You also saw it a lot around media factories. The idea is I get a bunch of like-minded individual organisations together and essentially have a combined private cloud. And then obviously we've got public cloud, so we're talking about Windows, Azure, AWS, Rackspace, Google data centers, whatever you want to use, right? And so that brings us to hybrid cloud. And most people think of hybrid cloud as, hey, I attach public cloud to my private cloud. Whether it's I attach Azure to my private cloud or I attach AWS to my private cloud, or I do both. And while that is true, how we want to think about hybrid cloud is actually how do you combine this and this together when you look across your entire portfolio of applications. So part of my application is going to run private cloud infrastructure as a service. And we're actually seeing a lot of private cloud organizations start to build a platform as a service style capabilities, right? Or does part of my solution need to run in the community cloud as an infrastructure as a service offering? And then do I actually need to run part of it in a public cloud as a platform as a service offering? Or is there something I can consume from a software as a service offering from a public cloud point of view? All right, so we kind of look at it in this multi-dimensional way. And then how you make a decision about when you look across your portfolio of applications tends to kind of fall into some of these considerations. There's this idea of relevance and agility of application. Right? So if I'm looking at my whole suite of on-premise applications, how relevant is this thing going to be to the organisation moving forward? And your decision process might be, well, the organisation, it's end of life, so I'm going to leave it on-premise. Or you might actually say it's end of life, so I'm going to throw it into infrastructure service in the cloud because I don't really, there's not a lot of control that needs to be put around it. There's not a lot of agility I need. It basically sits there and does nothing. There's obviously the cost idea. How much is this costing me to run? How much is it going to cost moving forward? Age and maturity. If you've got a 30-year-old application, which is a thick client application, tightly coupled to the database, I can tell you now it's unlikely to play very well, even in infrastructure as a service in any sort of cloud platform. Yeah? And so how easily can you actually move it into a cloud environment? And how, if you're talking about hybrid cloud, how can I tease it apart? You see this a lot with this idea of access sprawl within an organization where businesses have created thousands and thousands of access databases, right, or applications based on access databases, and the IT department is pulling their hair out, assuming they've got hair, not like me, pulling their hair out going, well, I've got now mission critical systems or business critical systems running on access sitting on someone's hard disk. So how do I take that and try and at least create some backup around it or try and so you see a lot of interesting solutions to this where people are trying to move the back end to, Azure in SQL Azure, for example, or SQL database to try and get backup, or you try and move the front end. So it's an interesting thing about the age and maturity of applications is how you kind of evolve that. There's also this concept of compliance, and I spoke about this morning when I spoke about DR. Right? Whether you can adopt cloud or not is going to be driven a lot by what compliance environment you live in. Right? There's both the offshore element of it, but there's also the out-of-state element, but there's also the element of it's not in your data center. Yeah? But on the flip side of that, one of the scenarios I'm going to go through is DR, right? Which is what I went through this morning. I'm going to show you what hybrid DR looks like. And I think nearly every single person who I've worked with that's adopting that is adopting that because of compliance. Their compliance says you need a DR solution. So I get a bill, I can either have a quote of $1.5 to $2 million to set up a DR solution, a geo-DR solution, or I go to Azure and it costs me maybe $10 a month, $100 a month. All right? The next one's this idea of performance and scale requirements, right? How is this thing going to perform if I put it in the cloud? How do I need to scale out? I've got some interesting scenarios I go through about where this worked and where it didn't work. And then the obvious one is hardware refresh cycle, which is kind of linked to cost. Yeah? So let's jump into the patterns and architectures. And so what I've tried to do is, I sort of went through the last 4 years of working in Azure and went through and went, okay, what scenarios and patterns and architectures have I seen where people have tried to tease apart parts of their applications and tried to run bits here and bits there and bits there. And this is kind of what I came up with, and I tried to frame it in these 5 areas for kind of ease of consumption. So there's this first idea of cloud bursting, right? And so there's some scenarios that go around that, but cloud bursting is basically, I don't have a permanent presence in the cloud, but I'm basically reaching out and consuming cloud resources as and when I need them, either dynamically or as a kind of scheduled process. The next thing is if I turn that around and make that a permanent thing, I get this idea of composite applications. How do I have cloud reaching into on-premise? How do I have on-premise reaching into the cloud on a permanent basis? Yep. The next one's this idea of resiliency, and this is where database DR comes into it, but also storage backup we'll talk about as well. And then access control is a big one. As people move into things like Office 365, right, you get this interesting problem that I now have, as you move into hybrid IT, you get this really weird thing that I now have this identity sprawl for my users. So how do I manage that, and what do the architectures look like for access control? And we're going to talk about both federated identity and cloud access control from a centralized point of view. Yeah? And then the last one that I see, which is getting a lot of momentum now, it hasn't had as much momentum as I would have thought in the last 3 years, is how do I offload my dev servers and my test servers to the cloud? Yep, what can I do, what can't I do? Make sense? So the first one I want to go through is this idea of cloud bursting. And for the purposes of this scenario, you can think of cloud bursting as I run the majority of my solution in a private cloud or community cloud style environment, right, using private cloud data sources. And then the idea of bursting is at some point in time, I want to be able to reach out to the cloud and utilize the inexpensive storage on the inexpensive compute it gives me. And so I want to have this dynamic or planned scale, right, up into the Windows Azure environment. And in this scenario, what I'm talking about is actually taking your entire application and shifting it into the cloud temporarily. Seems like an extremely odd thing to do, right? Why would I, if I'm comfortable with my application running in the cloud, why on earth would I have an on-premise environment? Yeah? And this is actually very common. I don't see it a lot with dynamic scale, but you see it a lot with planned scale when it's event-driven. So the classic example is the ESSA exams which happened in New South Wales, right? Which we got a big case study around, blah, 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 right? The idea that I want to push my solution into the cloud so that I can scale up to 100 servers to manage all the students in New South Wales, but then when that exam's over, I want to bring all that back down from the cloud so that the teachers can do localized reporting and localized management on that data. Right? And what I also do is I do a partial sync of data so that I'm not actually pushing up PII data or PII information. Yeah? So generally you see this type of push the entire solution to the cloud, right, when it's event driven. Right? So it might be a big one we've got coming up is the Olympics in winter, right? In December. And so what you'll actually see is you'll see there's a whole bunch of on-premise stuff running at the moment. And then when the Olympics come, they'll push a whole bunch of stuff to the cloud and then tear it down and descale it. Yeah? Now, what's interesting about this picture is it's actually wrong. You rarely get 2 arrows here. What you actually generally get is this. Because you're not going to do this because you create a multi-master problem. Right? So multi-master problem is I've got the same users updating cloud, I've got the same users updating premise, it's not going to happen. Right? The reconciliation logic on this database is absurd. Right? So what you actually get is this, and this is actually very common. Again, around those event-driven models. Now, the interesting thing is here is how do you do the data synchronization? And data's always going to be your problem, right? Because compute's a no-brainer. I pick it up, I slap it there. How I slap it there depends on what I want to do. Whether I can consume some software as a service, or I move it to PaaS, or most of these burst scenarios are I just pick up my VMs and I transport them into the cloud. And I'll talk about VHD mobility sort of at the end of the presentation. But so if I'm talking about Azure, my options around how I actually do this synchronization, because what I want to do is push the event up and then bring the data back down once the event's finished, so I can do localized reporting. If it's doing SQL database, I can use something like SQL Data Sync. Yeah. If I want to push the entire database up, the best option is going to be import-export or export-import. If I'm actually not moving to SQL database but SQL on a VM, then most people are going to use simply a backup or log shipping. And then for your blob and table, you're not going to use blob and table on premise, but if you've used file share data, you're basically going to have some sort of custom thing, or you're going to snapshot, put it on a VM snapshot and basically load it up as a drive. Yeah? The interesting thing about this, the applications that are most suited to this are applications which don't have complex integration requirements and don't have complex application infrastructure requirements. It's very difficult to do this if you've then you want to burst up within, if I look at the ESRI exams, I think the case study was they essentially bursted up. So they bursted up kind of a week before the exams, and it took them overnight to essentially burst up. They spun the instances up over about 30 minutes. And then essentially they tore it all down. They synchronized the non-PII data up, which took about an hour, I think. So that's fine, but then what you don't want to do is have to then spend a month integrating it back into the local systems. Right? So the other area you see bursting a lot is regional bursting. Right? So I see this a lot, especially as we evolve our data center footprint across Asia. Yeah? And there's kind of two models you see here. One is where I have a branch office, right, that I want to host in another country, or if you're an ISV, it's a solution I want to host in another country to put in place, essentially expand my business. So the idea is here, and again, the question is, well, if I'm going to go to the cloud, why don't I just go to the cloud? Right? And the idea is because my Australian customers, especially if I'm targeting enterprise customers, may not want their stuff in the cloud. Yeah, that's not what they're comfortable with. So what we see is we actually see a lot of Australian ISVs and a lot of Australian customers sticking with their private data centers for Australia, but then they want to launch into China, for example, or they want to launch into Singapore, or they want to launch into APAC generally, or Hong Kong. And if you want to get into China, what do you have to do? All right? You have to go there, you have to get some fancy internet service provider license, you have to partner with a local company, then you have to basically sign a whole bunch of contracts, etc., etc. Or you just walk up to one of the cloud vendors that are already there and say, can you do this for me and I'll deploy on your infrastructure. Yeah? And so that's something you see very, very often. But the most common thing that people think about when they think about cloud bursting is this one here, where I actually don't burst my entire application experience, I just burst a little bit of the compute. All right? So a big example here is high performance computing. Does everyone know what high performance computing is? Right? The idea is could be an Excel spreadsheet that I'm doing some complex risk calculations on. It could be actually a HPC server that I'm submitting a job on. I have a HPC server down here. Right? And then essentially all I do is overnight I submit that job up to Azure. Basically HPC blows that compute out, right? Sends the data with it, blows the compute out. Once it's finished, it collapses that and brings it down. Who's familiar with Green Button? It's one of our very early New Zealand case studies. They do all the Pixar rendering. So Pixar is one of their big customers. They do all the film rendering for that. they sit on Azure and they basically resell Azure. So green button, it's called the green button because if you buy RenderMan or if you buy one of the other rendering engines or apps they support, there's literally a green button they install in the app. And when you press that, instead of rendering across a farm you've got, they burst it to the cloud. All right? So things like rendering, HPC is very classic for this, where you don't have a user experience in the cloud, you're simply using very cheap storage that I can stand up and tear down whenever I want. Yeah? If you take this concept and make it permanent or make it a long-standing thing, you get this idea of composite applications. Yeah? And so in this case, I'm using cloud compute. And an example you see a lot here is master data management, for example. Right? So what I want to do is I've got a CRM system down here. All right? Let's say I've got dynamic CRM installed in my private cloud. And what I want to do is I want to add master data management to that. Everyone know what master data management is? So basically what I use it for is as customers come in, or as I enter search leads or customer leads into my CRM system, what I use a master data management system for in that scenario is I essentially scrub the data. And so what I do is I can use it both in a real-time aspect to say, hey, you entered Graham Elliott's, instead of H-A-M, you entered it, how else do you spell it? A-E-M, whatever it is, right? And so what that does then is it says, hey, did you mean this person? Right? And then what I do is overnight I push my entire data up to the MDM solution. Right? In this case it's going to be a SaaS solution. I scrub the data and bring it back down. Yeah? And so that's actually quite a common one we see as well, is this idea of permanently connecting that. And if you're going to look at permanently connecting that, one of the things I add beyond bursting is you have to ask yourself the question, how much do I want this Azure infrastructure to be part of my infrastructure? So instead of me using these as temporary resources, do I just want to use that as a infinitely, in quotes, infinitely scalable extension of my data center? And if that's the case, that's where something like Windows Azure Virtual Network comes in. So if you don't know what this is, it's essentially a technology we have which allows you to isolate a part of the Azure environment, create a secure connection between your environment and the Azure environment via an IPsec connection. Essentially, I'm creating a VPN between those two. So what I'm doing is I'm literally adding those, and I can domain join those servers, I can have those access my Active Directory on-premise, I can do a whole bunch of stuff. And so if you are permanently going to do that, that's fine for an infrastructure as a service deployment. Right? It's also fine for a platform as a service deployment, but if you're using an MDM solution, for example, or a rendering solution, or if you're using a DRM solution in the cloud, you're not going to be able to attach the virtual network to their environment. Yeah? But in scenarios where you're using a infrastructure as a service scenario, it is. The other thing then you have to ask yourself is, okay, well, if I have this scenario, do I also want to create a connection to my local data store? And so to give you an example of why you might want to do this is we did, so you might have read an article, Car Sales wrote an article with, I think, CIO magazine last year about how they use the cloud. And how they use the cloud is they basically have this idea of an on-premise data center which runs the majority of carsales.com. It's on-premise, it's like a local private cloud. And then what they do is they have this issue that, let's say Car Sales has 2 billion images, right? If you go onto the Car Sales site, it's got thousands of images for each car and times by billions of cars, whatever it is, right? What happens is their environment is actually front-ended by Akamai. So if you don't know what Akamai is, it's a content delivery network. It's quite a broadly used one, popular one. Which is great because their on-premise data centers don't have to have the power to serve up the images because Akamai does. They literally hit this problem where they wanted to release a new feature into their environment, but what would happen is they were going to change, for example, or add an image size instead of this big, it's going to be this big. Yeah? So imagine about 1,200 Akamai servers, all requesting about 1 billion images of various sizes that need to be resized and watermarked across the various car sales brands, car sales, CarPoint. So they call this thing an Akamai storm, and their infrastructure simply could not handle an Akamai storm. And so what they do is they basically have a permanent Azure infrastructure, which all its job is to serve up images to Akamai. But it doesn't actually hold the raw image, because the raw image for car sales is highly valuable intellectual property. So they store that in their private cloud. Yeah? And so what Azure does is Akamai, the 1,200 servers, when they know they're going to release, right? So Akamai every now and again will always ask for, for some images because someone searched an image that hasn't been accessed for 1,000 years, or someone posted an image on a forum is a classic case, and linked to an image on a forum that may not exist in that size anymore, but they don't want to show a broken link because they want people to click back to car sales. And so Akamai might come back and say, give me a server. So they always maintain, let's say, 4 or 6 of these servers sitting there just rendering these requests. But when these Akamai storms are coming, they basically blow that out to 300 servers. Right? Release the feature, Akamai just floods the servers and says, give me the image, give me the image, give me the image. And what happens is when the first server requests that image, we actually go back to the raw data and say, can you give me the image? I'll render it, I'll watermark it, I'll reformat it, I'll cache that in blob storage, I'll get rid of the raw image out of the cloud, and then any other of the 1,200 Akamai servers that ask for it, I'll just push it back. Yeah? So that's an example of where you might actually connect straight into the storage, where you don't actually want to push any of this data up to the cloud because it's sensitive. Yeah? If you flip that on its head a little bit, there's also this idea that instead of using cloud compute, I could actually just use cloud storage. And a classic example of where you see this is around, Scott gave the example of IIS logs. Right? More and more people are wanting to get insight into this massive amount of data that their on-premise applications are generating. And so what they do is they'll push it into the cloud and then attach some sort of analytic onto that, whether it's HD Insight, a Hadoop cluster, or whether it's simply some sort of analysis services view or cube over this data. Yeah? What is a slightly less abstract view of that is this. Does anyone know what Store Simple is? Yeah? So for those that don't, there's this concept called a cloud integrated storage device. Who uses a cloud integrated storage device today? Anyone? One person, wow. Okay, so what this is, and we own Store Simple now, by the way, which is why I use it as the example, but there are others. So what this is, it's a physical device that sits in your data center and acts as a local cache, but provides backup DR and archiving capabilities back into the cloud. So what you're actually doing is instead of saying, let's buy 100 terabytes or 100 petabytes worth of local storage, I'm essentially saying what I'll do is I'll put this thing in my data center, which provides a local cache, and I'll back-end it onto hundreds of petabytes of storage that's in Azure without having to pay for that storage until I use it. Yeah? So that is a very, very common scenario in enterprises now. Yeah? Essentially, how do I offload this massive amount of storage that's archival, backup? I don't really need it to be there, to be at my fingertips. It's not transactional, and I can push it off to the cloud without me having to have some archaic backup process or push process. Yeah? So that is a very common hybrid scenario, especially because we're pushing Store Simple like you wouldn't believe, obviously. And then if you flip the whole thing on its head and say, instead of having my user experience from my private cloud, let's put the user experience in the cloud. So what's the example here that you use all the time? E-commerce. Let's go click Frenzy. Whatever that thing was that crashed, right? So the idea is, let's take a classic e-commerce scenario, right? I need the cloud as a front end because I want that ability to, when I'm having a sale, I want to scale up, I want to scale down. I want to scale up, I want to scale down. Yeah? I want that infinite scale. Yeah? Or it could be just a line of business application that does, I essentially just want to offload my front end because I don't need the front end to be on my private data center. Or I may want to leverage the ubiquitous access I get from the cloud. So instead of exposing my websites here, right, I'll expose them up there, and then I'll create a secure Windows Azure virtual network. In this case, I'm going to create a site-to-site. You can also do, who's familiar with Windows Azure Connect? No? Okay, so we used to have this technology called Windows Azure Connect. It doesn't exist anymore. What it used to allow you to do was actually really cool. It used to be able to say, I'm a developer, for example, or let's take the HPC example. I'm a HPC user, high performance computing user. I want to submit things into my protected, isolated environment in Azure through a VPN, but I don't want to install a big VPN device for my entire data center. So I'll use what's called Azure Connect, and what we did is we used to just get this little agent, put it on the box, put the agent in Azure, and they used to create a VPN tunnel. That doesn't exist anymore. It's been replaced by a feature in Windows Azure Virtual Network where you can do, there's two modes you can run this in, site to site, which is what I would run here. In my HPC example, I would run client to site or point to site. Make sense? What was I talking about? Oh, so my e-commerce example, right? And so in this scenario, what's going to be sitting down here? SAP is the usual one that sits down here. Right? Or it might be my CRM data that sits down here. Or it might be my mainframe, although I haven't seen mainframe for a while, but I used to do a lot of host integration server work. Does anyone use host integration? Hey, 2 people, cool. I used to spend my life doing host integration server work like 20 years ago, but anyway. So we don't see that, I don't see that much anymore, but anyway, that's the sort of thing you're connecting down here, and you've got a number of options here. One is I can create this virtual network across the 2 data centers, or I can use something like Windows Azure Service Bus. So Windows Azure Service Bus is think of it as our loosely coupled messaging infrastructure. Everyone, if you're familiar with BizTalk, right, it's not BizTalk, but it kind of enables the same type of scenarios. And the first scenario when Service Bus 1.0 came out, the first thing we enabled was this thing called a relay service. And the interesting thing with that was the idea was instead of, if I want to talk, I'm going to fall off the edge here. If I want to talk from Azure or the cloud down into my data center, I have to break through firewalls, I have to break through NATs, I have to publicly expose it, I have to do a whole bunch of DMZ, blah, blah, blah. All right? So what this allowed you to do is instead of essentially the cloud reaching, or cloud services having to reach into your data center, what you actually do is Service Bus provides you with a cloud endpoint, and then down here you have a WCF binding which essentially creates a secure connection up. Right? So what we're doing is we're allowing you to traverse firewalls and NATs and providing you with a secure publicly exposed endpoint. Yeah? Service Bus also has queues, so you can do the same type of thing within a solution. And the other thing you see a lot is this. Why else would I might have an SAP solution and I don't have any users in the cloud, but what I have is a whole bunch of partners, right? And so I can use the same sort of relay service, or I can use this idea of topics and subscriptions to create more of a publish and subscribe thing. So I might want to use it to submit a whole bunch of order requests out, or a whole bunch of vendor requests out, or whatever it is, a whole bunch of notifications. And essentially what I do is I create a whole bunch of topics, I post to those topics, and then these partner systems subscribe to those topics and grab the messages, right? Without me having to create a lot of infrastructure on my on-premise environment to connect out to those environments or those users. The other one that we've just actually released is this thing called notification hubs. And so if you look at what one of the cloud tenants is, it's this thing called ubiquitous network access, which is something, in theory, all cloud platforms, whether it's private cloud, community cloud, or public cloud, should give you. But in reality, a lot of private clouds are still locked down. So if I want to access and do push notifications out to mobiles, or pull requests to mobiles, it's a lot easier if I've got an endpoint sitting in the cloud, which can securely connect down to my on-premise data center. So that's kind of the different types of patterns I see from a composite application and a bursting scenario. How are we doing for time? Perfect, cool. Okay, so let's talk about resilience. Yeah, and so the most basic thing we see with resilience is, hey, let's use Azure as a backup, right? It's actually an extension of that use cloud storage scenario. So use cloud storage where I've got Store Simple sitting there, or a cloud integrated storage device, is essentially this in a sophisticated way with a big hardware investment, little hardware investment I should say, small hardware investment. Whereas this is basically, let's use what you've got, let's create a whole bunch of backups like I normally do, but instead of storing those on tape, let's push them into blob storage. All right? And hopefully one of the sessions you went to today or yesterday told you that you get 3 local replicas and 3 remote replicas. So you're pretty safe, you're not going to lose that data. Yep. The other thing that's interesting here, which I'm actually seeing a lot of, people are actually starting to snapshot their VHDs and actually push those up into the cloud and use the cloud as a deployment mechanism for those VHDs. So instead of storing all these VHDs on servers, especially you see it a lot for the dev workloads, if I want to create a whole bunch of dev images, what's interesting about this is the extension of that scenario is I actually take those backups, restore them into either SQL database if I can, which is probably unlikely I can if I haven't already orchestrated this too, but more likely SQL Server to VM, and then I run it as a reporting environment, and an analytics environment. Again, similar to that kind of use cloud storage scenario we spoke about. The other thing I can do here is obviously SQL data sync, right? If I don't want to do that mass export, I can use SQL data sync. So SQL data sync essentially has 2 modes you can run it in. Or actually, there's actually 3 common scenarios we use it in. One is to synchronize between on-premise and cloud. One is to synchronize between cloud environments, and the other is just to synchronize within my own cloud environment to create a kind of a hub and a spoke type model. The extension of that is this idea about how do I do on-premise to Azure DR for SQL Server. So if you're in my session this morning, I spoke a lot about the fact that doing geo-disaster recovery with SQL database or Windows Azure SQL database is a difficult thing to do today and requires a lot of hand-rolling. And so most people that want hot HA tend to go for the more how do I actually use the inbuilt capabilities of SQL Server running in infrastructure as a service to do hot DR? And we're seeing a lot, and the extension of that is, well, how do I use the cloud for doing my DR? Right? And we see a lot of uptake around this because people have to do it now for compliance. Right? Whether it's FSMA compliance or whether it's SAS compliance or whether it's ISO compliance, you have to have a DR strategy in place. Yeah? If you do it, and wrong country, but you get the idea. Let's imagine that's Australia. If you turn it upside down, it kind of looks like Australia. Yeah? And so what I have here is I've got, excuse me, an on-premise replica, right, replicating to a secondary on-premise. The reason I do that is to get high availability. Because you're not going to use the cloud for high availability, you're going to use it for disaster recovery because your application is still on-premise. It doesn't make sense to do high availability with the cloud if you've got an on-premise app who's trying to talk to a cloud-hosted database. Yeah? And so what happens is obviously if this guy goes down, if both of those goes down, I lose my data center, at least I can fail over to my Windows Azure environment. And then we're actually getting customers now who are creating a secondary site, essentially lift and shift their infrastructure as a service into Azure, not with any reason that they would ever use it for high availability, but absolute worst case scenario, the business has said if a disaster happens, we are comfortable with running in the cloud for a reduced period of time while we mitigate the disaster so that we can continue with continuity. Yep. Or we can give business continuity. Yep. The reverse of that's also true. So you can actually use Windows Azure as your primary and then use on-premise as your disaster recovery. Yeah? With this one as well, this provides an interesting benefit. Depending on which technology you use, and we'll talk about that in a sec, what you want to do here is you actually then offload your backups to the secondary that's running in Azure. Yeah? Assuming you can have readable secondaries, which we'll talk about. And so instead of you having to export, create your backup, then push it to the cloud, I simply do my backups on that readable secondary, which essentially gives me, it offloads the compute requirements of backup from here. Make sense? So what technologies are supported? Oh, and by the way, now that, did anyone see our Oracle announcement? Yep, so a few of you. So we had a big group hug with Oracle about a month ago now, and so they will, which included a number of things. One of them is they will officially support Oracle in Azure. They will also provide guidance for doing that. We'll also work with them to optimize Oracle for Azure, and they'll also do license mobility, which is very cool. Right? So that doesn't have to be SQL, that can be Oracle. I couldn't tell you how to do it because I know nothing about Oracle. But this is how you do it for SQL. Yeah? Yeah? Currently, it's just for the database. Good question. So the question was, is that for the database or for the app tier as well? And the answer is it's just for the database at the moment. Yeah. So if anyone is interested in doing that, we actually have a technology adoption program we're running with some of our larger ISVs at the moment. But we can get enterprises into that as well if you want to test out what your on-premise Oracle workloads would look like running in Azure. So this is what SQL looks like though. So you have a number of options, and there's more options than this. There's obviously backup to URL and a bunch of other stuff, but these are kind of your DR options, right? The first one is availability groups. Second one's database mirroring. The third one's log shipping, and they are in order of preference. So the one you want to use if you can is availability groups. This is very, very funny because you cannot actually do availability groups across two Azure data centers. But you can do it between an on-premise data center and an Azure data center. The reason is to do availability groups, you need everything to be in the same domain. So you need a VPN between the servers. You can't create a VPN across two Azure data centers at the moment. You can do it between on-premise and Azure. So you want to use availability groups because it provides zero data loss. The scope is at the databases level, the database server level, not at individual databases. You can have 4 secondaries, and the cool thing, you get readable secondaries, which means I can offload my backup capabilities onto that secondary. The reason you wouldn't use availability group is if you're not using SQL Server 2012. We don't support clustering, by the way, and trying to do a geo cluster across Azure and an on-premise ain't going to happen anyway. So, from latency point of view, if people hadn't actually worked out why that wouldn't happen. Database mirroring as well. See, it says high safety mode. You're unlikely to be able to use high safety mode because, again, latency is going to be too great for high safety mode. You'd use high performance mode, which is async, which actually, so that thing there where it says zero data loss, that will not be true. There is a potential to lose data because it's asynchronous. Yeah. Now, the one thing I'll say about this is if you want to implement this, it's relatively easy. The technology is exactly the same as you use on-premise. And I said this morning, but I'll repeat it. The concepts you use are exactly the same. So if you're familiar with availability groups, it's exactly the same thing, but the implementation is very different. So don't take what you do on-premise and try and apply that to Azure. You need to go and download the step-by-step how to do it in Azure guide. Yep. But the other reason you wouldn't use availability groups, if you're not on SQL 2012 or you've already got a database mirroring infrastructure set up, you could just extend that to the cloud. Yep. And then log shipping is going to basically be backups for you. The next one I want to go through is this idea of federated identity, or let's go through access control. I'll go through federated identity versus centralized identity. So the idea of federated identity at a conceptual level is my application is not the owner of the identity. I want to offload the responsibility for authenticating users to someone else. And in this case, in my hybrid approach, I want to offload it to my local private cloud Active Directory infrastructure. Yep. Because I don't want to store username and passwords up here. And so you do that with this concept called federated identity. And there's a whole bunch of, this isn't a Microsoft thing, there's a whole bunch of WS Trust and WS Federation protocols which make this kind of an open standard. To the point where I think if you had logged on to, when you signed up for TechEd, you probably got the option to use I think you would have got the option to use your corporate account, or you would have, which isn't this, it's actually Active Directory in the cloud, which we'll talk about, or you would have got the option to use Live ID, Google, or a whole bunch of other, whoever supports federated identity, which is Yahoo, Google, Live ID, Twitter, Facebook, blah, blah, blah. Yep. And so the idea here is I authenticate against here, I don't authenticate against there. And how we enable this with Azure is this thing called Windows Azure Active Directory Access Control Service. The Active Directory means nothing, so ignore that. It's called Access Control Service. They added the Active Directory because it sounds cool in marketing brochures. Right? But this used to be called Access Control Service, and that's how we still call it. They just added AD on the front. So who's done federated identity before? Okay, cool, a few of you. For those that haven't, this is how it works. User has an application which might try and hit the public cloud application. We call that the relying party. It's the relying party because it's the one that relies on the identity. The relying party says, I have no idea who you are, right? I could actually create a trust relationship directly between my public cloud application and this identity provider through this thing called ADFS, Active Directory Federation Services, which is a token provider. Right, which basically takes a Kerberos token or the AD claims, wraps it into a nice open standard, right, and essentially publishes that out so other applications can consume that as a trust certificate. Yeah? So I could create that trust boundary, but what I actually want to do is offload that trust relationship to ACS. So my application doesn't actually know about my Active Directory down here. It has a trust relationship with Windows Azure AD ACS, and then I have a federation trust relationship between my identity provider, which is my ADFS server, and my ACS environment. Yeah?
Is ACS a brand new service?
No, it's very old. It's been there for since nearly day one of Azure, actually. It's like at least 3 years old. So there was originally ACS version 1, which only supported kind of web service scenarios and a few protocols. That's deprecated now. We now have ACS version 2.0, which supports a lot more kind of web interaction scenarios, so human interaction scenarios, not just web service scenarios. And you'll see this a lot. If you use any Microsoft kind of sign-in service, you will more or less be redirected to, so if you ever see, and I think you would have seen this when you did TechEd, you go to the TechEd sign-in page, and what it does, it immediately redirects you to a different page or a different URL. That URL is actually ACS. Yeah? And the reason it redirects you there is because you hit the application unauthenticated, if you hit the logon page or if you just try and hit an authentication, it goes, dude, you don't have a forms authentication token, you don't have an I have no idea who you are, so go and talk to this guy. All right? So then the browser goes, oh, okay, I'll go and talk to this guy, and this guy is ACS. And then ACS, I configure an ACS for this relying party. I want to use Active Directory Federation Services, I want to use Live ID, I want to use Google. And if you saw Scott Guthrie's demo, he had Azure, which is, think of it as AD in the cloud, which I'll talk about in a sec, but he also, I think, had Live ID or Google or something, right? And so then I hit that page, and then if I say, well, ACS, or if my only option is ADFS, then what will happen is it will redirect to here and say, hey, can I have my claim for my corporate authentication? And then essentially that gets packaged up, sent back to ACS. ACS will either pass that through as the token claim that it is, or it will transform it into a different format or enhance it with claims. You know, the rudimentary demo we do is, hey, you're Bob from down here, and what I'm going to do in ACS is actually have a role that says Bob as an administrator. I send those two claims in a token to the application, or to the browser, to the application. The application goes, oh, hi, Bob, I know who you are. Here's your authentication token that I'm going to recognize you on for now. We're talking, you know, milliseconds, this transform. This isn't a you know, so that's essentially what federated identity is. This actually is dying out a little bit, you'll find. It's still very much active if you want to use Live ID, Facebook, Google, that sort of stuff. If you want to use kind of open identity providers in the cloud. But from a identity provider in AD, what we're actually seeing more is this. And so we've got this thing called Windows Azure Active Directory, which this is actually Active Directory. This is not Active Directory, even though it has Active Directory in. This, whoopsie, that you can think of as Active Directory in the cloud, which pretty much what it is, with a lovely little pretty user experience on top. And so this is actually used primarily, or initially, this was used by Office 365. All right, so if you have an Office 365 environment, all right, you will actually be authenticating most likely against the Windows Azure Active Directory. Yeah? And Microsoft Dynamics CRM uses it now. Windows Intune uses it as well. You can use that for your own applications as well. All right? That's not hybrid cloud computing. The hybrid part comes with that little circle over to the left or right, depending which way, that circle over there. So the idea is I have my Active Directory environment here, and I can integrate it with my Windows Azure Active Directory environment. All right? And there's kind of three types of integration you do. The first is directory sync. And so to do directory sync, I don't know if anyone saw Scott's demo, you literally just go, that application downloaded, that's called directory sync. You basically you essentially go through the wizard and say, I want to add an on-premise Active Directory or create a relationship. It says, go and download this application. You install that application on your domain controller, click next, next, next. It actually sets up a synchronization schedule to synchronize directory objects into Active Directory, Azure Active Directory. That's option one, all right? Option two is you also do password sync. Password hash sync. You don't obviously sync passwords because they don't exist, but you do password hash sync or password sync. The idea then is I can come to my cloud application I've put here and log in as if I was with my corporate credentials. Make sense? And you'll be sort of sitting there thinking, why would I bother replicating my directory without the passwords? Because what am I going to use that for? And the answer is for the third scenario, which is single sign-on. So the third scenario is instead of me having to go to here, excuse me, and saying type in Graham E@Microsoft.com, here's my password1 corporate password, which it isn't, by the way. Then what I can actually do is if I have a security token service sitting on my Active Directory environment here, what I will actually do is this model, federation without ACS. That still doesn't use Active Directory. But what I then use Active Directory for is when you get a claim back, and even if you get a live ID claim back, it has one thing in. Actually, I think it has two. So the token has two claims in. One claim is a unique user ID, and the second claim is my name. All right, so it's friggin' useless. All right. The same as Active Directory. If you get a claim back from Active Directory, it will pretty much just say, you're Bob. But if I want to know, well, what roles does Bob belong to? Who does Bob report to? What org structure is Bob in? That's why I need my objects from Active Directory synchronized into Windows Azure Active Directory. Yeah? So that then these guys here can make intelligent identity decisions based on the single sign-on environment or single sign-on setup they got from there. Cool. The last one I want to go through is this idea of cloud dev test. And I actually thought, to be honest, this would take off big time like 3 years ago, but it didn't. And one of the main reasons is because we didn't have this Team Foundation Service. This is a fairly new thing. And so there's various ways I can offload my Cloud Dev Test, because Cloud Dev Test means a lot of things. In this scenario, what I'm talking about is I've never seen a scenario where people have created a remote desktop environment and put Visual Studio in that remote desktop environment in Azure and actually done physical dev in a virtual environment. It also breaks our license agreement, so you can't do it anyway. But even if you wanted to, the experience would be horrific, right? Because of latency. The world lives on latency in the cloud. But what this is about is instead of me hosting my own Team Foundation server, all right, or my own Git repository or whatever else you want to use, Subversion, perhaps, Mercurial, then what I actually do is I use Team Foundation Server, which supports Git, or you can use TFS project structures, to do my management and build. Yeah? And so I don't have to manage that locally, and I get high availability and blah, 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 and redundancy and that sort of stuff. And then the interesting thing here, and this actually happened before people did build, people started about 2 years ago, people being organizations, looking to use the cloud for how do I do load testing. Yeah? Which is an interesting concept because an application running in the cloud will will perform very differently than an application running on physical infrastructure or even virtualized infrastructure sitting in my private data center. But what this is very useful for, even if I'm doing a private deployment or a private cloud deployment, it's actually very useful to do application profiling under load. So even though I don't necessarily be able to say, hey, this is the exact performance characteristics of my app, what I can do is I can actually profile what the application looks like under extreme volumes with very little cost. Yeah? The other thing you see this a lot is people actually will deploy it out to a set of test users and they don't want to have to set up their own internal networks just to set up a test environment for external users. So I'll push a deployment out to the cloud so that I can essentially expose out and get user acceptance test feedback. The extension of that is then I actually use that. There's a preview of Build Server. You can sign up for Team Foundation Server. It does have some limitations, so if you want extreme flexibility around continuous integration, you can actually deploy TFS Build Server in Azure, which takes all of about half an hour to do. And then you actually link your Team Foundation Server account to the build server sitting in Azure, and you can control it all via Visual Studio, as if it's your own build server sitting there. And so then you can do continuous integration straight into Azure. It's a little bit more difficult with websites. It's very, very easy with cloud services, somewhat ironically. Slightly more difficult with VMs as well, because you need to do a lot of scripting to get the VMs to work, but it's getting there. And then you can actually, with the right scripting, actually get it to deploy to a private cloud, assuming you've got some sort of FTP site you can hit to deploy the package. So that's what Cloud Dev Test is like. And we're actually seeing a huge uptake in this, especially in smaller organizations, right? The mid-market organizations and ISVs are lapping this up. Enterprises are still, tend to tightly control their source code, which is fair enough. So what I went through is this idea of cloud bursting. So dynamic, or more realistically, planned scale bursting into the cloud. Doing regional bursting to expand my presence or to set up a regional office, or doing compute bursting for rendering, HPC, that sort of stuff. We looked at composite apps, resilience, access control, and the dev flexibility. I've got 2 more slides to go where I just want to quickly have a look at some of the cloud enablers we spoke about. And so our goal in Microsoft is if you choose Windows Server or if you choose Windows Azure, you should have a common integrated experience across both. Yeah? And so we spoke about this idea of I can create secure site-to-site network connectivity with virtual network. I can do point-to-site connectivity with the same thing. My app layer connectivity and messaging, service bus, data synchronization we spoke about, identity and access control. The one we didn't speak about, which is probably for all you IT pros sitting in the audience, you're probably tearing your hair out saying, you didn't speak about this, is this one, app monitoring and management. Yeah? And if you look at most of the enhancements we are putting into System Center, and caveat, I'm not an IT pro guy, but I've seen a lot of cool demos. I'm a dev guy. Yeah? If you look at all the enhancements we're putting into this, it's about how do I manage my hybrid IT environment? How do I manage cloud-based VMs as if they were on-premise VMs, and how do I manage my on-premise VMs? And how do I allow dynamic shifting of VMs across each of them? And that is why we're working on this thing as well, called VHD Mobility. And so this whole premise of I can shove things into the cloud, I can tear it down, I can push things around, is based on this concept. And if anyone ever used the VM role in Azure, which was pre-infrastructure service, beyond the state issue, the big problem was it wasn't a VHD, so you couldn't just grab it and pull it up. What you can do now is take an on-premise VHD, sysprep it, and push it up into Azure. Yeah? Or you can do the opposite. I can take a VHD and pull it down into my own data center. What's more interesting is we are working with, there's a whole bunch of cloud consortium partners which are standardizing on a whole bunch of standards. One being security, the other being this guy, right? VHD standard. So Amazon now supports, not suggesting you go to Amazon, but if you wanted to, Amazon now supports taking one of our VHDs and putting it in Amazon. So you can now take these images and push them around service providers. One thing we didn't talk about in our DR scenario this morning was about multi-cloud DR. The level above where we went to today around hot HA and hot DR is actually some of our extremely large customers who need extreme availability. They actually go with a multi-cloud approach and they actually DR across cloud vendors. Yeah? Because there are some scenarios. So if anyone uses Azure and remembers the storage outage of 6 months ago, where one of our certificates expired, everyone remember that? That took out all of our data centers, all right? Anyway, so I just want to summarize with 3 quick things. Hybrid's a long-term reality. If you look at most of our investments across Windows Server and Windows Azure and System Center, it's all about evolving this capability to just run stuff anywhere. And so your users should be able to come up and run hybrid IT as a service in your enterprise and essentially just choose where they want it deployed and have it managed consistently. Obviously, your goal needs to be to combine the best of all your options to balance what your goals and constraints are. And our goal is to provide you with a common experience across app identity management virtualization to be able to do that. Okay? So I'd like to thank you, especially seeing it's the last session of the day before the party. I'd love to thank you for coming. And if you've got any questions, come and grab me. I'll be here for a while. So thanks a lot.